Chemical bonding part 2. In the box provided in your answer booklet, draw the electron or Lewis structure of an atom of calcium. Okay, so let's do that now. Let's look at calcium, and I'll give you a minute to try to figure that out. Remember, the electron dot structure is only valence electrons. Calcium's configuration, symbol Ca is configuration 2882. So how many dots? So calcium would be Ca, 2 dots together. Start with the first 2 together. Next, in the box provided in your answer booklet, draw the electron dot or Lewis structure of a chlorine atom. Okay, so look at chlorine. The symbol would be Cl. Valence electrons, configuration 287, so you need 7 dots. So chlorine, 1, 2, 3, 4, 5, 6, 7. Now next, in the box provided, draw the electron dot structure of calcium chloride. Well, let's look at the charges here. It's a metal and a non-metal, so we need something ionic. Calcium would be a +2, and chlorine would be a -1. So we're going to need 2 chloride ions to 1 calcium ion. So we'll put the calcium in the middle, boxed, +2 charge. Chlorine's on the side. And then, of course, remember, it's brackets, charges, and 8 dots around the non-metal. Now, of course, the metal has an octet too, but the convention is to place the dots around the non-metal. And there's your final answer. Notice opposites attracting, the calcium in the middle, negative attracted to positive, and positive attracted to negative. So that's what they're looking for to give you full credit. Okay. Let's continue. Next. In the space provided in your answer booklet, draw an electron dot diagram for each of the following substances. Okay, calcium oxide, they tell us an ionic compound. So just like before, we need a calcium ion, Ca+2. Let's look up oxygen, that would be a -2 ion, and O-2. Since they both have the same amount of charge, we're only going to need 1 of each, just opposite signs. So we'll draw the calcium, +2 charge, brackets, charges, and the oxygen with a -2 charge, brackets, charges, and 8 dots around the non-metal. That would be calcium oxide. Next, hydrogen bromide. Well, hydrogen has 1 dot, that's a non-metal. Bromine has 7 dots, group 17, so 7 electrons. Let's draw them separate first of all. So we're going to have to place these electrons that are shared between them. So your final answer would be H, place those 2 electrons between them, and draw in the remaining electrons. There it is. There's your hydrogen bromide. Then, next one is carbon dioxide. Now remember, carbon dioxide, as I had told you in the notes, is one with the 2 double bonds. So I would just remember the carbon dioxide that way, because it's going to be hard to draw that. All right, let me make some room here, in fact. I mean, I could show you how to start that off if you want. Let's do it that way. But in the end, I would memorize the carbon dioxide. So here's the carbon in the middle, and the oxygens. Carbon has 4 valence electrons, which we spread out. The oxygen has 6. 1, 2. I'm going to go clockwise on this one. 3, 4, 5, 6. And that was counterclockwise. And clockwise on this one. I don't know, clockwise from counterclockwise, that's sad. And then, again, the electrons should have to be placed between them, so there you have it. That would give you octet for this oxygen. And here, we'd have to place these electrons between them. So your final answer is going to have 2 pairs of electrons here and there, or in other words, 2 consecutive double bonds. So let's draw that here. And you'll see why I mean it's easier to just memorize this one. There you have it, a double bond here and a double bond there. Double-double. That's what they're looking for, and that's a lot of work. 2 points, but that's the answer. And continuing, let's see what, I think this is the almost last question in that. Testing of an unknown solid shows that it has properties listed below. Low melting point, nearly insoluble in water, a non-conductor of electricity, and relatively soft solid. Well, these pretty much go together. Properties 1 and 4. If it has a low melting point, then it has to be a soft solid because it has weak attractions between the particles. State the type of bonding that would be expected in the particles of this substance. Well, these are properties of molecular or covalent compounds. Explain in terms of attractions between particles why the unknown solid has a low melting point. Well, as I said before, if it has weak intermolecular attractions, it has to have a low melting point. So weak intermolecular attractions, or forces of attraction is what they're looking for here. Then explain why the particles of this substance are non-conductors. Well, to be a conductor, you have to have freely moving electrons, and these certainly don't have it. The electrons are being shared between the atoms, so there's no free moving electrons to enable conductivity. Okay. This works out so much better with the left hand. It's ridiculous that in all these reviews I never used my left hand. It's sad. I learned something new today. Next, naphthalene, a non-polar substance that sublimes at room temperature, remember solid to gas, can be used to protect wool clothing from being eaten by moths. Yeah, naphthalene makes mothballs. Explain in terms of intermolecular forces why naphthalene sublimes. Well, in order for a solid to turn directly into a gas and skip the liquid phase, that's what sublimation is. That means the attractions between the particles are very weak. So we're looking at weak intermolecular forces of attraction, or IMFs, or IMAs, whichever abbreviation you want. Explain why naphthalene is not expected to dissolve in water. Well, it won't dissolve in water, because remember, like dissolves like, and that's in our solutions unit, but we'll mention it now. And since water is polar and naphthalene is non-polar, they won't dissolve. So water is polar. Naph is non-polar. So they are not alike. Therefore, you would not expect them to dissolve in each other. Okay, that was good.